Now interface circuit. Many times I used this interface circuit in the previous lecture. Now this is the system bus. To the system bus interface is connected, and to the interface IO devices are connected. Now this is IO devices, this is the interfacing circuit, and this is a system bus. Now one side to the interface, one side it is system bus is connected, and another side IO devices are connected. Now these IO devices, where the IO devices are connected to the system bus, to the interface, this point or this node is considered as a port. Now here we will call it as a port. And here these ports are classified into two different ports. One is a parallel port and another one is a serial port. Now what is parallel port means? Now this is the processor and interface circuit, and this is the IO device. So now from the processor to the IO devices, always interface, always the data transfer takes place parallel. So what is the meaning of parallel and serial means what? At a time, all the, now if I say 8-bit means what? All 8-bit will go from processor to the interface at a time. So now serial means what? One after the other bit will move. Now if 8-bit means what? First bit will go, after the second bit will go, after the third bit, like that 8 bits will go. So one after the other. At a time here in this case, in the serial, at a time only one bit will travel. In the case of parallel, at a time, all the bits will travel at a time. So from the processor to interface, always the parallel transfer takes place. Means what? Processor will send all the bits at a time to the interface. But coming to the interface to the IO devices, for few devices, it will send the data parallelly, and few devices, it will send the data serially. Now, where the data it is sending parallelly, that port is called parallel port. Now, for which devices it is sending serially, and those devices connected to the interface, that port is called serial port. Now, in this lecture, we are going to analyze the parallel port. Now, where the data transfers between interface to the IO devices, parallel transfer is taking place. Okay, now here, this is the input. Now, this parallel port for the input device. If the input device is connected to the parallel port, means what? Data transfer is taking parallelly, and input device is connected. Now, keyboard is the input device. Here we have connected. Now, if this is the interfacing circuit, if you see the interfacing and the keyboard, here keyboard switches are there. When the key switch is pressed, then for corresponding electrical signal, one code is generated by using the encoder. And debouncing circuit is means what? When the key is pressed, so sometimes it will generate the multiple, because of the bouncing bouncing mechanism, it will generate the multiple signals. So that should be eliminated by using the debouncing circuit. And after that, now if you see here, in between the interface and the keyboard, data bus is there. Now here the data transfer takes place in parallel transfer. That's a parallel code. Parallel transfer takes place, and also valid signal is there. Whenever the key is pressed, so it will generate the valid signal and along with the data. Now it both will received by the interface, and this data is placed into the data in register. Now, if you see the processor and interface, in between data bus is there, address bus is there. This is the control bus. In the control bus, we are placing the read or write command, and master ready, slave ready. This is nothing but about control and timing signal. So these are also comes under control and timing signals. Now here we are assuming that the data address bus is 32-bit. To do the analysis of this circuit, we are assuming that it is a data is address is 32-bit address. And here, because of the master ready and slave ready signals are introduced, the data transfer is asynchronous bus protocol we are using. Now, what is the bus synchronous protocol? Asynchronous bus protocol we have studied in the previous lecture, buses. So there, please check once again the timing diagram, you will understand it. Now we will try to analyze if the processor want to read the data from the keyboard, what happens. Now already I have said that keyboard, when the key is pressed, the corresponding code is generated by the encoder, and if any multiple signals are bouncing signals are there, then that will be eliminated by the debouncing, and the proper signal, the valid signal will be sent on the data, and it will send the valid signal also, and it will be placed into the data in register. When the data in register is filled, then the SIN bit becomes 1. If the data in register is empty, then thus it will show it as a 0. Thereby what? Data in register is empty. So now if it is filled means what? The status bit, it will show that this is 1. SIN bit is the one of the bit of the status register. Now if this is a status register, in this one of the bit is what? SIN. Okay, now if whenever the processor before going to read the data from the data in register, processor first always reads the status of the interface register. Now first it will place the address on the address bus. Which address? Status register address it will place on the address bus. And after decoding, now along with the address, it will place the read signal. Along with the address, it will place the read signal. Why? Because status register, it is reading the content of the status register, so it will place the read signal. And after decoding the address, it will place the master ready signal. When the master ready signal is received by the interface, it will send the slave ready signal, and along with the slave ready signal, it will place the content of the status register onto the data bus. So then processor will read the status. And if after reading the status, if the SIN bit is equal to 1, then processor plays the address of the data in register, and it will place the read. Again, it is reading the data in register command. So it will place the read command, and it will send the master ready signal. When the master ready signal is received by the interface, again it will send the slave ready signal. Along with the slave ready signal, it will place the data in content onto the data bus. Thereby processor will read the data. This is what happens inside the processor when the input device is connected to the parallel port. The same analysis we will try to do with the circuit. This is the block diagram, and this is the circuit diagram. Now already we have assumed that the address bus is how much? 32 bit. In this 32 bit, 31 bits we are applying to the address decoder. Now these 31 bits will go to all the address decoder of all the interfaces. But whichever if the address of the keyboard is placed, only this decoder will be enabled. Remaining all the interface decoder will be disabled. Now those interfaces we are not showing here. Now this become bit what? After decoding, these bits got 1. Now if the processor want to read the status, then A0 bit is equal to 1. If the processor want to read the data, now this is the data in register. If the processor want to read the data in register, it will place 1. So first processor will place the address of the status register. Means what? A0 bit is 0, remaining all bits are same. So now here this decoder bit become 1, and because of this is 0, now here again this bit become 1. And after decoding and after now when the address is placed, at the time it will place the read signal. Now this also 1, this also 1. And because the address is 0, now this bit is 0. And now after that master data signal will place. So this bit 1, this bit 1. Now if you see here, this is AND gate, this is AND gate. AND gate, all bits are 1. Here one of the bit is 0. If any one of the bit is 0, output is 0 in the case of AND gate. Now this is 1, and here this bit is 1 because this is connected to here and this is connected to here. This bit is 0, and this is an OR gate. If any one of the bit is 1, then this becomes 1. Now this symbol is nothing but what? Buffer. Buffer means what? Whatever the input data you will give, the same data will be available at the output. But this is not the normal buffer. This is the tri-state buffer. Means one more enable signal is there. When this bit is equal to 1, then only the input data will be traveled to the output. So the input data will be appeared at the output. Now if this is 1 means what? This 1 becomes available at the output. Means what? Slave ready becomes 1. Now along with the slave ready, it will send the status bit. Already I said that. Now this 1 makes this buffer enable. With that what? This SIN bit will be available on the data bus. So now the processor will read the data bus. Thereby it will read the D0 bit. If the SIN bit is equal to 1 means what? Processor understands that. Now how it become 1? When the key is pressed, then the data key is pressed. That code is stored into the data in register. Along with that, it is sending the valid signal. This valid signal makes this SIN bit is equal to 1. So that's why processor reads the SIN bit 1. And after reading the status register, and if it is 1, then it understands that the data is ready. Thereby processor sends the address of the data in register. That is nothing but what? Remaining all signals are same, and the A0 become what? 1. By keeping this 1, now this is 0, and this is 0, and this is 1. So this is 0 means what? Now here it is 0, and this is 1 means what? This bit is 1. Thereby what? Again the slave ready is again 1 only, because any one of the signal is 1 means what? It is 1 only. But instead of selecting this SIN bit, now because this read data is 1 means what? It is enabling this tri-state register, buffer register. So now tri-state buffer register is nothing but what? This acts like a switch only. Whenever this bit is equal to 1 means what? Now here all the switches becomes what? Closed switch. Now whatever the data is available here, that will be placed onto the bus. So this is called what? This is a tri-state buffer. So whenever this bit is equal to 1, this buffer will be enabled. Thereby the data available on this register will be appeared on the data bus. Thereby processor will read the data. Now this is the analysis of the circuit. Now for the parallel port, if output device is connected, means what? Processor want to send the data to the output device, then what is the procedure? We will try to analyze. Now here, this is a processor. If processor want to send to data to the printer, and printer want to print the character, then first we will try to analyze the data transfer between interface to the printer. Now the printer is ready, then it will send the idle signal to the interface. Then if the data is available in the data out register, then S out is equal to 1. If the data is full, then S out is equal to 1. If the data is empty, now this register is empty, then S out is equal to 0. Now if the data is full, then S out will become 1. If the printer want to print the character, then it will send the idle, then it will check the S out register, then the data will be placed onto the data bus and it will send the valid signal. Thereby what printer will print the character. Now after printing the character, if the now once the data is transferred onto the data bus, now the data register is empty, so S out bit is equal to 0. Now again, if the printer want to print the next character, it will send the idle. So but this S out bit is 0. This now the processor need to send the next character. So for that, what we'll do, processor first it will read the status of the interface by keeping the status register address here and read, and after decoding it will send the master signal. After receiving the master signal, then the interface will send the slave ready signal and it will place the status register content onto the data bus. Thereby processor will read the status register, and with that it will understand that it will read the status S out bit. S out bit is 0. So processor understands that the register is empty. Thereby what? Processor will place the data on the data bus and address on the address bus at the same time. And also it will place the write instruction. Means what? For read it will place 1. For write it will place 0. So write 0 means what? 0 bar becomes what? 1. So processor will place these 3 at a time. And after decoding the address, it will place the master ready signal. And after receiving the master ready signal, then the interface will send the slave ready signal to the processor. At the same time, this whatever the data is available in the data bus will be loaded onto the data out register. Once the data, if it is loaded, then S out becomes what? 1. Then the data out will be placed onto the data bus. Then the printer will print the next character. Now this we will try to analyze with the circuit diagram. Now the circuit diagram, if you see, it is almost same like a input device only, input interface circuit only. For a status read, it is almost same, but only the difference is what? This is a S out bit is connected to the D1 bit. S in bit is connected to the D0 bit. Now the processor will check the D0 bit. If this is 0, then processor will send the data into the data out register. Now, whenever if it is sending the address of the data out register, now if it is 1 means what? This load data will be enabled, thereby what? It is enabling the output register, thereby whatever the data available on the data bus will be placed on the data bus of the printer circuit. That is only the difference. Remaining analysis is same like a input interface circuit. Now this is an exercise for you. Now you do the analysis of the output interface, the remaining, for how it is reading the status and how it is reading data is transferred to the output device. Same. Now this is AND gate. Same analysis. Now only thing is what? When it's reading, it will place 1 here. Thereby what? This become 1. Now when it is writing the data, then this bit becomes 0. Thereby what? This bit is 1. So the load data is enabled. If this is enabled means what? This register is enabled. This whatever the data is available on the data bus will be placed on the data bus of the printer. So this is the output interface analysis. Now coming to the combined I/O interface means what? Input device, output device, both devices are connected to the same interface circuit. Now here you can see the data in register, data out register, and SI in bit and S out bit. SI in bit, S out bit will be available in the same status register. In the same status register, one of the bit is SI in bit, one of the bit is S out bit. So to read the status, it need one address. To read the data, it need one more address, and this for this one more address. So 3 addresses are needed. That's why it is taking the lower 2 bits instead of lower only 1 bit. It is taking 2 bits means what? Thereby if it is taking 2 bits means what? It will get 4 combinations: 0 0 0 1 1 0 1 1. In these 4 combinations, 3 combinations are used to read the status register, data in register, data out register. Now this is also exercise for you. The remaining analysis is same like the interface, how we analyze the input interface. So this is the exercise for you. Now with this we finish the parallel port. In the interface, parallel port is finished.